Hello and welcome back for Unit 8, Lesson 9, Part 2. In this part of our lesson, we'll be reviewing double angle identities as well as half angle identities, and then using them to prove identities. So similar to the identities we learned previously last lesson, we are going to, in the sum and difference angles, we're going to be given these formulas on an assessment. Again, that means that you shouldn't just forget them completely, but you should know how to use them. So focus more on how I'm using them rather than actually recalling the equation itself. Okay, let's look at these double angle identities. Why is it called a double angle identity? Well, look, if I have sine of 2 theta, that is saying if I multiply the angle by 2, then there's an equation that I can use to find that angle. And notice there's only one equation for sine, and there are 3 equations for cosine and 1 equation for tangent. And notice the 3 equations for cosine, that they all have differing kind of capabilities, right? Because you have a cosine and a sine in this equation. You just have a sine in this equation, and you just have a cosine in this equation. So you can use them depending on what information you have. Let's look at number 1. Here in number 1, we are finding trig values. So it says if sine of theta is equal to 5 over 13, and theta is from 0 to pi over 2, find cosine 2 theta. So let's say that we weren't learning this today. You didn't know that we were talking about double angle identities. You'd have to be able to pick out this double angle and say, oh, that's a double angle, so an alarm should be going off. Hey, I need to use or think about double angle identities. Because right now it's easy because we're learning it in this lesson and we're talking about double angle identities. In a few lessons, or when we review, it won't be as easy because it will be in the mix with other different questions. So here we go. Sine of theta is equal to 5 over 13, cosine 2 theta. If I'm given sine and I'm trying to find cosine 2 theta, which equation should I use? Well, I have sine, and I'm going to use this middle equation because it has sine theta in it, and I have the value of sine theta right there. So I can go ahead and just say, hey, cosine of 2 theta is equal to 1 minus 2 sine squared. And then I'm going to make the substitution here, okay? And so I can write this. This is equal to 1 minus 2 times 5 over 13 squared, right? Because sine squared, or sine theta, that quantity squared, that's equal to 5 over 13. That's what was given to me. And then we can just calculate this, and you get 1 minus 2 times 25 over 169, which is equal to, work this out, 1 minus 50 over 169, which is equal to 119 over 169. There you go. Now we'll come back to this, but just note that we are working in this first problem in the first quadrant, right? It'll come into play in number 2. Number 2 says if cosine of theta is negative 7 over 25, and we are working in the third quadrant from pi to 3 pi over 2, find tangent of 2 theta. So I'm going to go ahead, and for this question, I'm going to draw a graph. And just note that I'm in the third quadrant. So this is quadrant 3, okay? We'll come back to that in just a moment. But think to ourselves, okay, we're trying to find tangent of 2 theta. Tangent of 2 theta, we don't have any information about cosine of theta, right? So it's like, well, how am I going to use this information given to find tan 2 theta when my equation doesn't have a cosine in it? Well, that's where you brainstorm, you begin to try things, and come over here to quadrant 3 and sketch of what this might look like on your graph. So if cosine of theta is in quadrant 3, again, I know it's in quadrant 3 because of the restrictions given to me, is negative 7 over 25. So if that's theta, theta is adjacent over hypotenuse. This means, I'm looking at my graph, this is negative 7, and that is going to be negative 25. Now in a minute, it won't really matter, right? But do note that then this would be, when you go to solve this for the other side right there, so you use the Pythagorean theorem to solve for that side, and you get 24. But this is a negative because if you look where we are, we're in quadrant 3, so that's going to be a negative number. I know it's a little bit confusing because we're talking about distances on a triangle, but we're working in the coordinate plane, so that is a negative 24 there. Now, how does that help us? Well, from there, we know that tangent of theta is equal to the opposite, negative 24, over adjacent, negative 7. So tangent of theta is equal to 24 over 7. Now that's helpful because when I go to write this definition of the double angle identity for tangent to theta, I get 2 times tangent theta all over 1 minus tan squared. Well, now I have what tangent of theta is, 24 over 7, and I can just plug it in to these spots. So this becomes 2 times 24 over 7 divided by 1 minus 24 over 7 squared. And then this becomes a big arithmetic problem where you're just multiplying things out. So the top is 48 over 7. The bottom simplifies to 1 minus 576 over 49. And if you want to keep going here, right, you would change, you have to simplify the denominator. So it'd be 49 over 49 minus 576 over 49. And let's see, do we keep going here? Sure, let's keep going. So 48 over 7 times, now what I'm about to do is I'm going to do 576 minus 49, which is negative 527. Then I'm going to take negative 527 and I'm going to put it on the bottom of the fraction because I'm going to keep change flip and put 49 on the top. So this is negative 336 over 527. Done. All right. So yeah, if you're stuck, you can't figure out how to use the information given, you might have to try and draw a picture. Okay. You can try number 3 on your own. Next, half angle identities, similar to the double angle identities. You know, what do you do when you're trying to half your angle? Okay, there are these equations. Notice that these equations are plus and minus. So let's go ahead and look at one of these problems. Let's skip number 4. Let's go to number 5. Number 5 is pretty fun because, well, let's read it. If tangent of 2 root 6, tangent of theta is equal to 2 root 6, and theta is between 0 and pi over 2, find cosine theta over 2. So again, you have to identify this is a half angle. So you'd be thinking, oh, we should be thinking, you know, half angle. Well, what is the half angle identity? It's this, plus or minus 1 plus cosine of theta over 2. Now again, how does this help with this? Well, we have to be creative here. How can this help us? Well, similar to the number 2 here, where we had to draw a picture. Here, I'm going to do something creative. And this is what I call a Jedi move in math, is when it feels like you're using the Force, when in reality I've just worked these problems out a lot of times before, so I kind of know what to do. But for you, it feels like I'm using the Force. So this is a Jedi move. I'm going to recall this Pythagorean identity. And it's tan squared plus 1 is equal to secant squared. Now, how would that help? Well, this is relating tangent to secant squared. And secant squared we know is 1 over cosine. And 1 over cosine is going to be helpful because over here we have cosine. So let's see if this works. So what I'm going to do is, I know that 2 root 6, I can plug this in, 2 root 6, I'm going to square it, plus 1 is equal to, I'm just going to write secant squared for right now. Now I'm going to simplify 2 root 6 squared, and that actually is 2 times 2 is 4. Root 6 times root 6 is 6, so that actually becomes 24 plus 1 is equal to secant squared theta. 25 is equal to secant squared theta. So that means that 5 is equal to secant theta. Now, this comes into play, right? Because when I take the square root of both these, I technically get a plus or minus here. But we're in this quadrant, the first quadrant, where everything is positive. So I'm only taking the positive value of 5. Okay, not the minus value, right? So I know that secant of theta is equal to 5, which means that, well, I'll write it like this. Cosine of theta, 1 over cosine theta is equal to 5. So cosine of theta is equal to 1 over 5. Ah, now we can use this for that, and we can find what the half angle is. Let's go for it. So cosine theta over 2 is equal to plus or minus square root of 1 plus cosine, sorry, I know what cosine theta is because we just solved it. So 1 plus 1 over 5 over 2. Nice. And I can add this together. Now, remember, this is a plus or minus here because we're in the first quadrant. This is just, I'm just going to accept the plus. So I'm going to, oh, no, oops. I'm only going to accept the plus. So just the positive. Now I simplify. So square root of 6 over 5 divided by 2. And simplifying this, 6 over 5 divided by 2 is 3 over 5, square root of that. And then I can do the whole multiply the top and the bottom by 5, and so you'll get square root of 15 over 5. There it is. So we had to use this Pythagorean identity to find out what cosine was equal to, so we could use this equation. The last thing that we'll do is we'll prove some identities using the double angle identities. Again, it's going to be up to you to be able to figure out which identity you should use, but for right now, it's helpful when you're proving this, look for the double angle and then try and substitute for the double angle, right? So as with all proofs, we're going to start with the more complicated side, and we're going to work our way to sine squared. Now, one thing I want to say is, please don't write this. This should not be in your proof, right? Why should that not be in your proof? I'm asking you to prove that this green is equal to the orange. As soon as you write this in your proof, this is equal to this, that's like saying, all right, Mr. Josh, here, I'm just going to write down what you told me to write down. Or tell me, like, hey, can you prove that, red is equal to blue, or the sky is blue? And then you say, okay, the sky is blue. And it's like, well, you didn't prove it. You just said what I'm trying to get you to prove, right? So you can't write that statement. So just keep it to one side of the equation. So I'm going to do cosine squared theta. And now watch. This is a double angle, right? And think about it. We're trying to get to sine squared. So what substitution would we want to make? If you go back to the double angles, we're trying to get to sine. I might be tempted to do this one or this one. I'll do the one that has just the sine squared in it and not the cosine squared in it. So I'm going to do cosine squared, and I'm going to write minus, I'm making this substitution in, 1 minus 2 sine squared theta is equal to, oh, sorry, I almost did that thing I told you not to do. And now let's see what happens when we simplify. So I'm going to distribute this negative sign, distribute accordingly. So cosine squared theta minus 1 plus 2 sine squared theta. Okay, now again, we're trying to get it to sine squared theta only. Watch this, okay? I'm going to write this next line. Cosine squared theta plus sine squared theta plus sine squared theta minus 1. Now, what did I just do? What I just did was I took 2 sine squared theta. That's like saying 2x squared and splitting it into and splitting it into x squared plus x squared, right? So I took 2 sine squared theta and I split it into sine squared plus sine squared, okay? And what I do with that, well, I took 1 sine squared and put it here, and the other sine squared and put it here. Then I took that minus 1 and I just moved it out here. I can do that, it's fine. How is that going to help me, though? Well, here's the gloriousness of what I just did. This right here, cosine squared plus sine squared, is a Pythagorean identity. The value of this is 1. So then I'm going to rewrite everything else. Plus sine squared theta minus 1. And now you can see 1's go to 0, and I'm just left with sine squared, which is what we were trying to prove. So you have to do some tricky manipulation in some of these, but you are definitely using a double angle theorem or double angle identity in this, because we're learning about double angles. Try 8, 9, and 10 out. And that's it.